Section 5.5, page 1, the substitution rule. So we've already learned the basic antiderivative formulas in the last couple of lectures, but now we're going to go ahead and take an antiderivative of a much more complicated or sophisticated problem, because essentially we're going to undo a chain rule. And if you really focus on this problems having a chain rule quality about them, it'll help you solve them. So to recall, a chain rule is where we have some function, we'll say y, where it is this operation happening on another function. So the f of x function is happening to a g of x function, which is happening to an x variable. So that when we take the derivative of y, we're going to have to take the derivative of that master or main function that's happening to some variable, or in our case, another function, but we can't ignore the fact that that function itself can be differentiated. So just kind of for some review, let's take the derivative, not the antiderivative, even though that's where your mindset might be, of sine of x squared. So I would think of, I know how to evaluate a sine function. It just happens to be a sine function of something. So I'm going to think of that something as g of x, where that really equals x squared. So I can just focus on, hey, I know the derivative of the sine is the cosine. Oh yeah, but it was of something, some function. So I'm going to have to remember to also multiply by that derivative, where we said g of x is just x squared, and the derivative of x squared is 2x. Okay, so now we're ready to discuss U substitution. Specifically, we'll start with indefinite integrals, meaning we're not evaluating from a to b. Notice there is no a and b value. So I'm asked to evaluate, even though I'm not plugging in a and b, I'm still essentially taking an antiderivative. So I look at this problem and I notice I've got an x squared and an x. So it's a much more complicated problem than before. And so what I'm going to do is essentially take what we got this answer to be and try to get back to this question. So we want to let u equal the innermost function. We already know that we're going to let g of x be the x squared because we've seen it, but we'll talk more about ways to strategize how to find u. But we're going to focus on, we have the cosine of something. That something is x squared, so we're going to call that u. I need to take the derivative of the left side, which would be du dx, and the derivative of the right side would just be 2x. But since we're going to focus on just du, you could think of multiplying both sides by dx, so it cancels off on the left and shows up on the right. Really, you're just doing differentials where the derivative of u is 1 in terms of u, and the derivative of x squared is 2x in terms of x. But we'll work on this notation just thinking of it as kind of putting the dx at the end. So going back to my original question, I'm going to first reorder the question. I'm going to take the cosine of x squared and put that first, and then I'm going to scoot the 2x next to my dx. The reason I did that is now I can focus on cosine of something squared, or in our case x squared, where we're letting x squared be rewritten as u. All of that other stuff, the 2x dx, I'm saying is equivalent to du. Really important that we put both the u in the function and have the du notation on the end, so it's clear which variable we're integrating over. Now I'm going to take the integral of the cosine of u squared, sorry, just u, which is sine of u. I took the antiderivative, used up the du when I took my antiderivative, and then because it's an indefinite integral, we need to put plus c, if you remember, because we have some constant that could always exist, even if it turns out to be 0. Now, this is great, but if you look up at my question, there was no letter u. There was no variable. Everything was in terms of x's, not u's. So now I need to substitute back where we said, hey, wherever we had u, we should be putting x squared. I've got my answer, the sine of x squared plus c. So is that really If I took this derivative, do I get that question? But you'll see that we come back, yeah, I started with sine of x squared and got the derivative to be cosine x squared 2x. So if I turn around and integrate that, do I get the question back? I did. We've got the plus c piece. Okay, I mentioned that you want some techniques when it comes to finding u, the best u choice. Focus on it being a chain rule, and it might come naturally, but otherwise look for the innermost function. I talk about the largest exponent, and you'll see it throughout some of the examples that sometimes that can be a way to focus on the problem too. But here's what's important. You want to let u, the substitution piece you're using, be some part of the integrand. That's the thing we're integrating, so that the derivative is also inside that integral that's part of the integrand. That is the most important part. It's fine. Pick the wrong u, and then when you go to find du dx and it's, not there, then start over and pick another u. Here's an example straight through. Again, the directions would just say evaluate. We see the integral symbol, so I want to take a antiderivative, but wait a minute, here's my variable x that I'm integrating over. It's part of a binomial that's trapped in parentheses that are locked with an 8 exponent. So maybe you think of that as being the largest exponent. Again, that terminology may not make the most sense, but I do have an innermost function that I'm evaluating. So I'm going to think of that as my g of x, but it's always g of x that becomes u. So I would rather just have to evaluate u to the 8th. That makes a lot more sense to me. But there's another nuance to this particular problem. When I take the derivative of u in terms of the x variable, I get a 3. So really my du part that I want to stick on the end, I've got 3 dx. I've got the dx, but I don't have a 3 in my question. So what I need to do is divide that 3 out. So if I divide the right side by 3, I just have that dx that I have, but that ends up putting the reciprocal, a 1/3, as part of my du. So when I substitute dx, I'm going to need to put 1/3 du in place of that dx, in addition to the binomial. Remember, anytime you're integrating with a coefficient, you can pull that coefficient out and just focus on u to the 8th du. So I'm going to keep this exterior coefficient. I'm going to take my u to the 8th and take the antiderivative by adding 1 to the exponent, which gives me 9. So I'll multiply by the reciprocal of that, and I've got my plus c. You could argue the plus c is multiplied by 1/3, but it doesn't change it from the fact that it's still just a constant. So I'm going to multiply 3 and 9 to get 27. I'm going to add my exponents to get u to the 9th. But remember, our question had an x in it. We need to focus on the x variable, not the u. So I need to substitute back. Where I saw u, I need to put the binomial 3x plus 9. I've got my answer, I'm done. I encourage you to check your answer, but be careful because a lot of people come, check their answer, and then they'll box the last thing they wrote, which is actually the question. So if I was to take the derivative, I'd have my 1/27th out front. I'd bring my 9 exponent in front of my parentheses. I'd subtract 1 from my 9 exponent to get an 8. And then I'd take the derivative of the inside, where the derivative of 3x is just 3. The derivative of 1 is 0. And so I can simplify my 9 and 27 to get my 1/3. I actually had the 3 that I'm going to move out front and also cancels with my 1/3. And I now have what should be the original question, and it was.